Hello again, people of the internet. Today, this is going to be kind of a meandering review of me talking to the all-powerful, all-knowing ChatGPT version 4. I've kind of talked to it before about monads and kind of read some things on the internet, but, I like to kind of explore these topics in a conversational way and then try and explain them. So, this is my little query here, and then obviously this is the response. So kind of the first question that I asked it, could a monad be thought of as unwrap a value, apply it to a function, then wrap the result? And then it goes into its response. In functional programming, a monad is often thought of as a design pattern that allows for the composition of functionally isolated computations. Your description of yada 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 captures the essence of a monad, but is a bit simplified. So then it goes into the different operations that it's composed of. Bind or flat map, or this bind symbol here in Haskell. It says takes a wrap value, it unwraps it, applies a function, and then returns the new wrapped value. And then this is unit or return or peer, takes the unwrapped value, puts it into the wrapped context. And then it talks about the monad laws, which I still don't have a real good grasp on this as far as the laws, the left identity, right identity, and associativity. And we'll go into more of my questions on that. So this is talking about different things that I want to do with it, build a SaaS empire. So then I asked it, give me an example of a monad in Haskell. And here it kind of goes through the maybe monad, and kind of my understanding of it is saying, hey, you can have just whatever the type is, or nothing. So in the case that there's some kind of failure, you'll get nothing, and then in the success case, you'll get a just value. So it kind of gives some code here. Some more code, some more explanation. And I asked it, is monad a type class? And I guess, in my understanding, type classes are kind of like a more powerful version of C# interfaces. That's kind of where I left off on the type class definition. In Haskell, here's the response. Yes, in Haskell, monad is a type class. A type class in Haskell is essentially an interface that defines some behavior. So yeah, it's basically like an interface. With some extra abilities to abstract. So here's the return value that basically says, hey, I'm going to take this, value A, and I'm gonna wrap it, and give you kind of this this wrapped A, monadic A. So I don't think return is really necessarily the most descriptive, self-descriptive name for it. Although I'm sure a lot of this comes from pure mathematical background. So in a kind of an imperative context, I think of return as basically wrap A. So that's kind of the way I think about it. Bind, it takes that wrapped value, applies it to a function, and then gets the wrapped value back. So there's the monad definition there in Haskell. So going back into the maybe monad, understanding the monad type class, blah, blah, blah. It keeps on saying, this can be particularly useful when scaling your SaaS applications. So then I asked it, how would you implement the monad with an interface in C#? And it kind of goes through that, C# class here that it generated with the maybe monad. Kind of shows how you would chain those together. I'm gonna go down here a little bit more. Yeah. So yeah, this is going through the maybe monad. I don't want to revisit all this. This is just more formatting stuff. Really don't care about that. That's more formatting stuff. Simple monad to write. This just gave me the identity monad, which really doesn't do anything. And then I said, hey, quiz me about monads, one question at a time. What are the two primary operations that a type must implement in order to be considered a monad? Return, which wraps a value, bind, which unwraps a value, applies it to some function, and then rewraps it. And it said, yeah, that was correct. 3 monad laws, left and right identity and associativity. And then it asked me about the maybe monad. In the context of the maybe monad, what does bind operation return when applied to nothing? And that also returns a nothing value. That's not that complicated. Next question, was the primary use case for the either monad in Haskell? Not really sure. And then it basically told me that it's useful for kind of telling us why a computation failed. Yeah, so then I asked for, give me an example of the either monad in action. Kind of shows us some of the logging functionality that you can get with that. And then this is the thing that I really didn't understand as far as being self-descriptive, the left and right identity. It's basically the context of the left, like left of what? Well, it's left of this bind operator, so the return is left of the bind operator, which is this guy here. That's kind of what it's referring to, but it doesn't really tell you a lot about, like, hey, what's the function here, or what's the meaning behind left and right identity. So it's basically saying that these two things are equivalent, that if you basically take a value, you wrap it, and then you run it through the bind, which unwraps it and applies it to this function, it's the same thing as just taking this raw a value and then running it through this f function. So that's not really that hard to understand. Again, it's talking about the right identity. And then I asked, left identity means if I have a function f and value v, the wrap version of v run through bind will be the same as v run through f. And I said, yeah, that's basically it. And then I said, hey, I don't understand return v. What does that mean? And is it basically saying here in the answer that return is a function that takes a plain value and puts it into monadic context. So it's return basically just means take a value and wrap it. Again, this is coming from, I assume, pure mathematical background, but I think a more descriptive name here would be something like wrap in monadic context, and that's kind of what I put down here. So maybe a better, more descriptive name for return would be wrap in monadic context. Probably not spelling that right, but oh well. And of course, this is all through ChatGPT because I don't really have the time to go through and read a bunch of category theory and deal with pretentious mathematical people who don't want to help programmers. That's kind of the gist that I've gotten from a lot of the Haskell community. So anyway, I'll be using ChatGPT because it doesn't have an ego and it doesn't really have an attitude to defend. So a lot of this will probably be wrong, and I make no apologies for being wrong. This is a learning in public exercise, so do with that what you will. So this is me asking, why does left come into here? Like, that doesn't help. Like, as a programmer trying to get stuff done, that doesn't help me do anything. And that, here's ChatGPT basically saying, hey, the left part refers to the operation on the left-hand side of the equation. Return A states that, so this is what it's saying. It's basically saying that the return part is on the left side of this bind operator. So I'm sure there's some math reason that someone will be sure to go into pedantic detail, which really isn't helpful in the context at the level of programming. So definitely do that in the comments and I'll pretend to care. So it's basically saying that, this is coming from a pure mathematical background. So yeah, it's basically saying left versus right comes from the mathematics theory of monoids and monads. In this context, left and right refer to the position of the monadic operation relative to the function or value it's being combined with. So left identity, it's left, right identity, it's on the right side. The return here is on the right side of the bind. So keep scrolling down here, keep scrolling down. So left and right terms are just mathematical terms denoting where the wrap value is in relation to the bind operator. So it's telling me, yes, that's what it is. So then I said, hey, explain the right identity here. It's saying the right identity law for monads state if you have a monadic value and use the bind value and feed it to the return function, you should get back the same monadic value you started with. So you have a monadic value here. You apply the bind, which unwraps it, and you rewrap it. It's the same thing as the wrapped value. It's nothing too spooky. It's a lot easier when you write this all out with more self-descriptive names, but of course you always have the trade-off of terseness and verboseness. So once you kind of go from the verbose version to the terse version here in Haskell, this will look a lot less intimidating and spooky. So I'll just keep on scrolling here. Yeah, so basically it's like a simple kind of identity. Yeah, it's not that impressive. And then I asked it, so it's basically the same as doing nothing. It seems kind of redundant. It said the right identity law serves as a fundamental consistency check for the behavior of the monad. I guess I don't really understand why that matters if it's not really doing anything. But hey, that's probably just me not knowing things about category theory. Okay. Yeah, so basically, right identity is a do-nothing identity operation. Left identity is a statement like, if you have a function f and a value v, wrap value function v through the bind operator is the same as v run through f. That's basically saying, yes, that's correct. And then this is just me complaining again about left and right identity aren't very useful names. Yeah, again, me complaining. It's very important to complain. Okay, and it's talking about associativity. That's just basically saying that the order doesn't matter in terms of the laws that it has to adhere to. It's not really that interesting. Okay, and then this is me not quite getting the associativity laws because some of the functions themselves are not associative, like division, where the order matters. I still don't quite get this, so I'm probably gonna have to go back. Yeah, this was just some Haskell syntax that I didn't really quite get, apparently. This is a lambda function. Yeah, I'm gonna have to revisit a lot of this. Asking it to rewrite it in something that I understand, like C#, not really. Still learning the basics of Haskell, so kind of getting somewhat of a translation helps with this. So I don't think I quite got that right, but yeah. So yeah, there's a lot here. The way that I'm thinking about it, I'm trying to scroll down here a little bit. Yeah, keep on scrolling. Okay, here's kind of what I wanted to get to. It says, it seems like a whole lot of what a monad does allow for short circuiting and exception cases. So it's basically the way that I see it as far as what it gives you, what a monad does for you in a programming context. is it allows you to create chainable functions with exception handling type logic. That's basically the way that I see it. And then talking about the maybe monad again. There was some other thing that basically I wrote later, but yeah, basically the way that I see monads is it's a way for you to chain operations together and kind of abstract away some bit of exception values into a wrapped value. So I don't think it's that big of a concept. I think there's just a lot of spooky mathematical language around it that makes it seem harder than it actually is. So anyway, that's just kind of my ramble for today. See ya. Bye.